Hi, this is Mr. Adams from Midwood High School, and this is a video on nuclear reactions. We learned in class that the neutron to proton ratio governs whether or not a particular nucleus will be unstable or not. And if a nucleus is unstable, it would want to undergo a type of reaction or transmutation to gain stability. Okay? And when we have nuclear reactions, all we have to do, we have to make sure that the mass numbers, okay, and the bottom numbers are equal on both sides of the reactant, the reactants of the reaction, the reactant side and the product side. Now, the bottom numbers could be either charge in terms of if it's a particle, or it could be an atomic number if it's an element. Okay, an atomic number tells you the number of protons. When you're doing these problems, folks, please always use your reference tables, okay, because they have a lot of valuable information on them. For example, they have tables N and tables O in particular. For example, this table right here. All right, this table right here is very helpful. It shows you the particular notations, okay, and symbols. Okay, so I'm moving over here. So you have this, so you should be looking at it right now. Okay, as we're about to do these problems. All right. Okay. Now, when we do nuclear reactions, right, you can be given them like what's in the bottom left corner right here. Okay, they can have spaces, and as you have to fill in the particular blank, or you can be given problems like this where they have it in the word form, but they all basically mean the same thing. Alright, so what you're going to do, you're going to pause the video, right, and you'll do the problems in the bottom left, and you'll do these problems over here, and we'll go over them and see how we do. Okay, first one, we have uranium-238, right, with atomic number 92, okay, and that is, we see, is undergoing alpha decay. Now, they won't tell you on the test in a problem like this is that it's alpha decay. All right, more in a problem like this, they might say it's alpha decay. Okay, now the thing is, even if they don't tell you it's alpha decay, right, they say the substance is undergoing a nuclear reaction or nuclear decay, you can look on this particular table and the decay modes are right there for you. Okay, so don't forget the fact that you can use this table to find all the decay modes. You match it up and you get it from there. So even if they didn't give you the decay mode, but they gave you a particular substance, you can still figure out the reaction. Okay, alright, so we have alpha decay, guys. So all you have to do is realize that if we have 4 here and 238 there, we know that there must be 234 in the top, right, for the top number. And if we have 92 in the bottom here on the reactant side, and there's just 2 here on the product side, we know we have 90, okay, for the atomic number. So what you simply do, you go to your reference tables, right, and see who has atomic number 90, all right, and that looks like thorium, TH. So you put a T right there, capital T, lowercase h, and you're done. That guy's solved, all right, so that's the first one. All right, moving to the next one, we have iodine 131. Now, the top numbers always, once again, guys, the top numbers are the mass numbers, all right, so don't forget that. All right, so here we go. All right, so we have 0 over here. It's beta decay, so electrons for our purposes have 0 mass. So the top number again will simply be, okay, will simply be 131. All right, so I'm going to write 131 right there. So 131 is our top number. All right, so we have 53 in the bottom for iodine right there, right? So what plus -1 gives us 53, all right, and that would be 54, all right. So what we do, we look at our reference tables, and 54 gets us what? 54 gets us Xe, okay, so Xe, xenon, is our missing guy in that particular problem right there, and we move on, all right. Okay, the third one. We have carbon 11, okay, with atomic number 6, and it's forming boron, okay, with atomic number 5, right? So right off the bat, we see that we have 11 on the reactant and product side. So the top number has to be 0. All right. The bottom number has to be 1, because 1 plus 5 gives us 6. Okay. And we look for what substance, and we move on. Okay. We have iridium, right? 174 undergoing alpha decay. All right, so we know from the word decay, right, that we talked about this already in class, that anytime you have a decay, particles will be emitted, particles will be given off, particles will be released, and to show that, you put it on the product side. Alrighty, so we find iridium, which is going to be for us, okay, IR, alrighty, and 174 goes there. Alright, so we have to look on our reference tables. So we look at our reference tables to find iridium, and that just so happens to be 77. Okay, so let's see, 71, okay, 75, 77, iridium, good. Alright, so we put a 77 there. Alright, we know it's undergoing decay. It's going alpha decay, so you find an alpha particle. From experience, alpha particle is 4,2 He. Okay, alpha particle is helium without electrons. All right. So what's missing? Simply, we put 170 in the top. We put 75 in the bottom, because 75 plus 2 gives us 77. Okay, what substance has 75 as its atomic number? The substance Re. Okay, and you're done. You move on. We have platinum 199. So platinum just so happens to be PT, right? Okay, 199 goes in the top. We look for the atomic number of platinum, which just so happens to be 78. Okay, once again, it's undergoing decay, so whatever particle will be on the product side is beta decay. So we know beta particle is 0, -1 E. So what substance is missing? We know that 199 goes in the top again, because 0 plus 189 gives us 199. So on both sides we have 199. In the bottom, we simply put 79, because we know 79 plus -1 gives us 78, and it just so happens 79 gives us a U. All right, good. We just make gold. All right, now we have to be careful here, guys, because over here it says positron emission. All right, so once again we have decay, emission. That also is going to give us something on the product side. All right, so we go again. Okay. So sulfur 31, all right, so sulfur is S, right? And 31 goes there, that's the mass number, the protons and the neutrons. All right, 31 on the top. Now sulfur's atomic number just so happens to be 16, right? So I'm going to do an arrow. We're just going to go to positron emission. A positron is 0, +1, E, right? All right, now plus, it's going to be 31 again in the top for the mass, but it's going to be 15 in the bottom, right? Atomic number. So what it has, atomic number 15, that just so happens to be phosphorus, all right? And you're done. And last one is Krypton 76. Okay, Krypton just so happens to be Kr. Okay, Krypton's a noble gas. Krypton's atomic number is 36. That goes in the bottom. Okay, the 76 refers to the mass number, so 76 goes in the top. Now, be careful now. It says electron capture. Now, capture taken in, you must show it on the reactant side. So please make a note of that. Capture goes on the reactant side. So what happens is we're going to put electron here, 0, -1 E on the reactant side, right? Arrow. Now what forms from that? Okay, so what's going to happen is 76 will still be on the top, but in the bottom we will have 35. 5, because negative 1 plus 36 gives us 35. And what substance has atomic number 35? Br, bromine. Now notice the atomic number gives identity. All right. Okay, folks. As always, hard work plus sacrifice equals success. This is a brief video on how do you do these nuclear reactions. It could be given this form, or it could be given this form. Okay, either or. Just use your reference table. Go from there. You'll be fine. Okay, take care.